Okay, some things about exponents, what a negative exponent, most of you have probably seen this before in Algebra 1, but what a negative exponent means is it's in the wrong side of the fraction. So, all numbers are fractions. So what this 7 to the negative 2 really means is this belongs in the other side of the fraction. So it doesn't necessarily mean it belongs on the bottom, it means it belongs on the other side. If I had something like this, see if it was negative down here, that means the 7 squared belongs up there like that. So as soon as you move it, it turns back to positive. So this 7 squared gets moved to the bottom, that gets moved to the bottom, and that gets moved to the bottom. So as a fraction, everything is gone on the top, so there's just a 1. And then that 7 to the second came downstairs, that 7 to the 10th came downstairs, and that 7 to the 9th came downstairs. So now we're simplifying these. This would be way too big of a number. That's like 7 times 7, and this one is 7, 7, 7, 7, 10 times, and then this last one is 7, 7, 7, 9 times. So I've got 2, and 10 is 12, and 9 more is 21 of them. So I have 1 over 7 to the 21. And that's some gigantic number there on the bottom. So you see here, there's no negatives. That means they all belong on the top. So on the top of that fraction. So you don't have to write a 1 when it's in the denominator. You do have to write a 1 when it's in the numerator. So that means 3 times 3 times 3 times 3, 9 times. And this is 3 times 3 times 3 times 3 times 3, 5 times. So when we count them all up, there's 9 of them there and 5 of them there for a grand total, 9 and 5 as 3 to the 14th on the top of that fraction. Okay. First of all, I see this negative 3 power there. Now the negative 3 is on the parentheses, so all of the parentheses are going downstairs. So 2 to the second is going downstairs, and then the negative 3 becomes a positive 3. Okay, so what that means is this 2 to the second is happening 3 times. That's what that 3 means. It means this package is happening 3 times. So I have 2 to the second, 2 to the second, 2 to the second. That means 2 times 2, 2 times 2, 2 times 2. So there's really 6 of them down there. So we have 1 over 2 to the 6th. Now that's small enough that we can almost do that. 2 to the 6th, there's 4, 5, 6. That makes 4. 4 times 2 is 8. 8 times 2 is 16, times 2 is 32, times 2 is 64. So you could certainly call that 1 over 64, but you can just leave it in terms of the base number. So here, this 3 means there's 3 of those packages. It means 3 to the third, 3 to the third, 3 to the third. So there's 3, 6, 9 of them. Now, when you have of course, there are some rules that you can just remember. I like to draw them out. So, of course, the rules when you have a power to a power, 3 to the third, then to the third. A power on top of another power is you multiply those numbers together. When you have multiplication, a power times a power, the base stays the same, and then you add those things together. So I like to see the visual, but there are some shortcuts of what's actually happening. Here I have 8 and then 10 eighths on the bottom. So here's the visual of that. This 8 can reduce that 8, which leaves 1 over 8 to the 7th, or 8 to the 9th. See, you can reduce fractions like that when they're multiplied. So in effect, what we did is we took the top power minus the bottom power. See, the top power was a 1, and we subtracted the 10, which gives us 8 to the negative 9th, and the negative means it belongs in the bottom. So here we could use that. This is just 9 to the third minus 9. So it ends up being 9 to the negative 6. And those negative 6 means the 9s belong in the bottom. So it's 1 over 9 to the 6th. That's the little mathy rule. Division means subtract the powers. Or the visual of what's happening is there were 3 9s on the top and 9 9s on the bottom. So those cancel, those cancel, those cancel. And see, we've got 1 on the top and 6 9s left on the bottom. So division is just subtract the powers together because they're canceling themselves out, really. Okay, now you have to be careful when you have combos like this. See that -6 right there? It's only on the y. So this is all over 1. So only the y6 is going to the bottom. And then same thing here. This -5 is not reaching the 9. x5 is going on the bottom. So what we end up with temporarily, so how you deal with the numbers is you just multiply them. So it's 4 times 8 times 9, whatever that is. 4 times 8, 288. So the numbers, 4 times 8 times 9 is 288. Then I've got 9 x's and 9 more x's. So think of 9 of them stretched out there and 9 of them stretched out there. So I have 18 total. That y package I already moved downstairs, and that one I moved downstairs. So on the bottom we have x5, y6. Now think about what this means. This means you've got a string of 18 x's. And this means we've got a string of 5 x's. Well, 5 of these can reduce 5 of these. So 5 of these, 1, 2, 3, 4, 5, can take out 5 of these, leaving only 13 left. So what we end up as the final simplification is 288 with x13 on top and a y6 on the bottom. So the numbers you multiply, then with the multiplication of the powers, you put them together, and then you see if anything reduces. So same thing here. Let's take a look at this one. The x10 comes to the bottom. So really the x10 is on the bottom. Okay, the numbers are 2 times 6. Then I've got y8 and y5 for y13. There's 8 of them there. 1, 2, 3, 4, 5, 6, 7, 8, and 5 more. That's where 13 comes from. And then we put the 10 x's on the bottom. Okay, now x's, so there's nothing there to simplify. That's the end. Okay, I like to do the power. So this is a power to the power. Now this 3 goes on there. That means 2 to the third, which means 2 times 2 times 2. That's going to end up being 8. A power to a power is multiply. So that's a -2 times 3. So that's a -6. And then this is a power to a power is multiply. So that's a v to the 12. Okay, so see, those u's are going to come downstairs. 2 times 2 times, so that just means 2 times 2 times 2. So that's 8. There's V12 still up there, and we put the U6 on the bottom. Okay, here, that's going to be a y -3, and then 5 times -3 is x -15. Okay, they both belong to the bottom since they're negative, so there's a 1 on the top when it's all gone, and then y3 x15 after we move it. And that's how you deal with exponents.